So in today's video, we are going to talk a little bit about writing formulas and naming compounds and just do a little bit of practice with the flow chart that I'm providing for you. So what you'll see on the screen is 4 examples and the flow chart for writing formulas. First one that we're going to do is sodium chloride. So what I do want you to do is just kind of forget about this part right here, this little mistake that was made. And we're going to start with the very, it's like the third box here. So it says, are there only 2 nonmetals? And what you want to identify is, are the elements listed metals or nonmetals? And when you look at your periodic table, you'll see that sodium is in fact a metal, and so you are going to identify that it is ionic. There are not only 2 nonmetals. So you say no, okay, the compound is ionic. Use the first word to determine the ion and its oxidation number or charge. So if you look at sodium on your periodic table, that's Na, and because it's in the first column, you'll see it's Na plus 1. And then chlorine or chloride is in the 7th column, and it's going to be a -1 charge. So then it says, anions that come from elements that end in IDE, and anions made of polyatomic ions typically end in ITE or ATE. And you use your common ions chart for exceptions. In this case, we have an ending in IDE, and we know that it's going to be chlorine. So then it says, create the formula by balancing the charges. Example, calcium phosphate. Well, in this case, our sodium has a +1 and our chlorine has a -1. So we're going to end up with the formula NaCl. So then the second one is dihydrogen monoxide. Are there only 2 nonmetals? What you want to be careful with here is that you have hydrogen, which is on the side of the periodic table with the metals, and you have oxygen or oxide over here. Even though hydrogen's over on the side with the metals, it's actually technically still going to be a nonmetal. So this does in fact have 2 nonmetals, and you're going to take a look here. The compound is covalent. Use the prefixes and the element's name to determine the number and the symbol. For example, diphosphorus pentoxide. You use di for 2 and penta for 5. It says, note, if no prefix is used, assume it represents mono. We don't have a scenario where no prefix is used, so we're going to just use what we have. So di meaning 2, hydrogen, that means we have H2, and mono is 1. Oxide means oxygen, so there's our formula, H2O. Because it's 2 nonmetals bonded together, we do not have to include the any charges because there aren't any charges, and we don't have to balance any charges because there's no charges. So that's that example. The third example is iron 3 oxide. So again, are there only 2 nonmetals? We go ahead and we look at our periodic table and we find iron, and it's going to be on the metal side of the periodic table, so we know it's going to be ionic. So the compound is ionic. Use the first word to determine the ion. So iron, Fe, and we know that the Roman numeral, even though it doesn't say, the Roman numeral represents the charge of the iron. So +3, and then you have oxide, which is O, -2. The charge on oxygen is always going to be the same. It's always going to be a +2 because of the column that is. It has 6 valence electrons, and therefore is going to need 2 more to reach a full octet. So that's how it gets a -2 charge. So then with that, we're going to need to balance them out. I know that in order to balance out my +3, I need to add a -2. Now I have more negatives than I have positives, so I have a +3. And then I need to add 1 more O -2 because I want to get to my common denominator of 6, or least common multiple of 6. Now, there are many different ways to go about doing that. You could do the crisscross method where you see that you have Fe plus 3 and O minus 2, and just multiply through to get 6 that way. But whichever way you use, your correct formula at the end is going to be Fe2O3. Notice that the subscript of 2 does not necessarily match the Roman numeral of 3. And the last one here, are there two nonmetals, calcium carbonate? Well, you will find that calcium is on the metal side of the periodic table. It's right here. And carbonate ends in ATE. So you know that you're going to have to look on the back of your periodic table under your common polyatomic ions to find it. So calcium, being in the second column, gets a +2 charge. Carbonate is a polyatomic ion, so you would write out your formula with a -2 charge. You see there's one of each, so you're going to go ahead and write CaCO3. Now, what if there was a different charge on calcium? Let's say we do something like manganese 4 carbonate. In this case, Mn gets a +4 charge and CO3 gets a -2 charge. In order to balance out the +4 on my manganese, I need another carbonate. So you end up with MnCO3 2. And you need the parentheses because there's more than one of those polyatomic ions. You can't put CO32 because that would change the formula of your polyatomic. Then we're going to take a look at some naming. So the first question, is the formula made with two nonmetals? If I look at BRO, bromine's a nonmetal and oxygen's a nonmetal, so the answer to that is yes. Then the compound is covalent. Name the first element. If there's only one, then use the element name. So in this case, we have only one, so we're just going to call it bromine. And then, way down here, it says name the second element by adding the prefix for the number and the root of the element name with the ending IDE. So we've got oxygen, and there is one. So we're going to use mono, and because it's oxygen, we're not going to say monoxide. We're going to say monoxide and cut out that second O to escape redundancy. Then we can look at NH4NO3. It says, is the formula made with two nonmetals? Note, polyatomic cations are ions and therefore aren't counted as nonmetals, such as NH4 plus 1 or H3O plus 1. In this case, we have NH4. And what you'll notice is that it's bonded to another polyatomic ion. So NH4 plus, if you take a look at your list of polyatomic ions, NH4 plus is ammonium. So ammonium, and then we know that it's ionic now because of ammonium. It says then the compound is ionic. Does the first element have more than one possible oxidation state? The answer to this is going to be no, because ammonium is only ever going to have a +1 charge. So it says name the positive ion by writing the name of the element, which we have already done. Then it says, does the formula indicate a binary compound, i.e. contains only two elements? And in this case, the answer is no. Binary would be something like NaCl, where there's one metal and one nonmetal. But in this scenario, we have a polyatomic cation and a polyatomic anion. So we're going to answer no to that question. So then it says, find the name of the polyatomic anion from the common ions. Don't add prefixes. So we've got NO3, which is nitrate. And you end up with ammonium nitrate. And the last example, it says, is the formula made with 2 nonmetals? And again, we're going to say no because Mn is manganese, which is metal. So we follow the flow chart here. No. Then it's an ionic compound. Does the first element have more than one possible oxidation state? And the answer to that is yes, because manganese falls in the D block, or the block with the transition metals. So if you find manganese along your chart right here, you'll see it's in that D block. It's a transition metal, so we're going to need a Roman numeral, and it explains this here. So it says yes. Determine the oxidation number or charge of this first element based on the anion it is paired with. Name this element followed by its oxidation number written in Roman numerals. So in this case, we've got manganese. And we need to pay attention to the charge that would be on the anion. Well, I know CO3 gets a -2 charge. So if I have 1 manganese and I have 1 of this CO3 with a -2 charge, that means that my positive charge has to balance out the negative. So it has to be a +2 charge. And then it says, does the formula indicate a binary compound? The answer to that is no. We have a polyatomic ion in CO3, which is called carbonate. And that is how you will use the flow chart. If you have any further questions, please send me an email or come in early and ask for help. Thanks.